You're watching the 5.6 lesson video on factoring trinomials, day 2 notes. Something that we are going to be doing today is really just a continuation of what was happening in the 5.5 factoring trinomial notes. So one thing that we want to just point out, when we're factoring, we're just rewriting the polynomial. So this is very important when it comes to checking our work. So let's dive right in. Looks like example number 1 is telling us to multiply, so to double distribute. So it looks like today we're going to again make the connection that what we're doing when we factor is the opposite of double distributing. Okay, so we're going to multiply 2x plus 1 all times x plus 3. And then inside the box, we're just going to multiply each of the two sides. So x and 2x is 2x squared. 3 times 2x is 6x. X times 1 is 1x. And 3 times 1 is 3. I have some like terms. We're going to combine them. 6x and 1x is 7x. So our final answer is 2x squared plus 7x plus 3. Okay, so as you can see in number 2, it looks like what we're doing here is we're graphing this particular quadratic equation, this trinomial. So we're graphing 2x squared plus 7x plus 3. A couple things that we're noticing, since we talked about the zeros in the last video, we have a 0 at x equals 3, and then we have another 0 that we're not 100% sure exactly where it is. It looks like it's at 0.5, but we're not sure. It's not at a nice, clean intersection of the grid lines. So it's saying, what are the roots? Well, we might say x is equal to 3, and then maybe x, that should be negative 3, right? X is equal to negative 3, and x is equal to maybe negative 0.5. We're not 100% sure. Okay, so what we're going to do now is we're going to show factoring using the box method, similar to what we were doing in 5.5, or exactly, I should say. So we will set up our box. We're going to pretend that we don't know the two factors, which we do because they're in number 1. But what we're going to do is fill in the box. So my 2x squared is always going to go in the top left. My tail is my 2x terms added together, and my positive 3 is in the bottom right. So what we need to do now is find two things that multiply to 2x squared. Well, if you're thinking 2x and x, you are absolutely right. Okay, what two numbers multiply to 3? Well, we have 1 and 3. That's pretty much it. We could try the 1 here and the 3 down here, or the 3 up here and the 1 down here. Okay, I'm going to do this first to show you why this particular method is important, especially when we have a coefficient in front of the x. Okay, so even though 3 and 1 are the only two numbers that multiply to 3, if we put the 3 here, we'll get 3x, and we put the 1 there, we'll get 2x. 2x plus 3x is not 7x. So a lot of times people will think, oh, 3 and 1 won't work, but that's not true. This 2 here changes things quite a bit. So I'm going to do a flip-flop of those two numbers. I'm going to put the 1 here and the 3 there, because now look what happens. 2x times 3 is 6x, and x times 1 is 1x. So 6x plus 1x is 7x. So we have factored this correctly. 2x, that was a positive 1 up here, so we're going to do plus 1, and x plus 3. Okay, so something that we just learned here is that even though the two numbers will multiply to this bottom corner, sometimes we have to do a switcheroo and flip-flop those spaces. Okay, so what do we notice about the roots compared to the factors? Well, the negative 3, so the root of x equals negative 3, looks like it's friends with this factor here. And then the root of 2x plus 1 is friends with, I'm actually doing that backwards, let me not be confusing. So the root of x equals what we think is negative 0.5 is friends with this factor of 2x plus 1. So we can still see the connection here that the root is the different sign as the factor. I'm not exactly sure what's happening over here, but that's something that we will eventually talk about probably in the quadratic functions unit. All right, for the sake of time, let's move on to number 3. So we're going to factor and check. So you got it. Set up that box. All right, let's factor. We're going to do everything that we've done in the past. So we'll put the 3x squared. So the x squared term goes in the top left. Minus 2, the constant goes in the bottom right. And then we have negative 5x up here. Okay, so what times what gives me 3x squared? Well, that I think is just 3x and x, right? There's no other two numbers that multiply to 3 other than 1 and 3. All right, or I should say whole numbers. Okay, now we need to find two numbers that multiply to negative 2. Notice how I'm trying to find what they multiply to first, and then this is going to come second. So my options are 2 and negative 1, or negative 2 and positive 1. And what that means I might have to do is a few different choices of switching this up. All right, so what I'm going to try first is I am going to put in the negative 2 down here and the positive 1 up top. Actually, I lied. I'm going to do the negative 2 up here and the positive 1 down below. So I'm going to try these two factors. Okay, x times negative 2 is negative 2x. 1 times 3x is 3x. 3x minus 2x is minus 5x. Oh, bummer. Now, what we could also try to do is do a flip-flop of these signs right now to see if that helps us. So that would just switch these around, and that still does not help us. So what this tells me is I think I have to put the 2 where the 1 was and the 1 where the 2 is. So let's do this. X times 1 is 1x, 3 times 2 is 6x, and we know that the signs of these two numbers have to be different. So how can we get 6x and 1x to combine to negative 5x? If you're saying that the 6x has to be negative, you are right, because 6x or negative 6x plus 1x is negative 5x. So negative 2 is my other number. So now I have my two factors. I'm just going to pull them from the top. So my final factored answer is 3x plus 1 all times x minus 2. Now if I want to, I can graph to check. So I'm going to do this on my first example so we can just get an idea of what checking looks like, because you're going to be doing this a ton when you're doing your practice. So 3x squared minus 5x minus 2. Hit enter, then we'll hit tab, and then we are going to graph our factored form of 3x plus 1 all times x minus 2. And then hit enter, and the two graphs match identically on top of one another, which means that we are correct. All right, let's move on to number 4. Number 4, let's factor, set up the box. Okay, so 2x squared top left minus 35 bottom right, and my tail is positive 9x. All right, let's factor this. So 2x times x is 2x squared, and now we need to find numbers that multiply to 35. So we have 1 and 35, we have 5 and 7. There might be a couple more. I'm going to try these for right now, or those might just be it. All right, let's see what's going on here. So, what if I put the 5 here and the 7 here? I don't really think the 1 and 35 is ever going to help me get to a 9x. I could be mistaken. So, I'm going to try the 5 and the 7 first. And then here I get 5x and 14x. Is there any way that 14 and 5 will become 9 if I add them? No, that gives me 19x. What about 14x minus 5x? Well, that works. And wait a minute, if I make this negative, that has to be negative. And are you guys seeing what I'm seeing? 7 times negative 5 is negative 35. So I think that we found our two factors. 2x minus 5 and x plus 7. Okay, so one thing that you're noticing, and I'm really trying to model this for you, is that there's a lot of not necessarily guessing and checking, but using your mathematical reasoning to help you find where the numbers go and which ones will actually work. All right, I'll do one more with you guys. Question number 6. Let's set this guy up. So we get 6x squared. My tail is negative 55x, and it's a positive 9. All right, something to think about. Somehow we are getting numbers to add to a negative number, but multiply to a positive. How could that be? Well, if you guys are thinking that both numbers have to be negative in this spot right here, then you are correct, because a negative times a negative is going to be a positive. But if we add a bunch of negatives together, it's just going to stay negative. Like, that's just like owing lots of money over and over again. Okay, well, this 6 is interesting because we could either have 2x times 3x, or we could have 6x times 1. I am going to use 6x times 1, well, 1x I should say, today, because what we're going to discuss in the next 5.7 notes is when those numbers are different other than itself and 1. Okay, so we have 6x times 1 giving us 6x squared. And now we need to figure out numbers that multiply to 9. So we have 1 and 9, and we have 3 and 3. Well, somehow I am going to have to get to negative 55. Like, that's crazy. So the only way that I think that that's going to happen is if I use a fairly large number. So I'm going to try my 9 and 1. So if I put my 9 here and my 1 there, I end up getting 6x and 9x, and 6x plus 9x. I mean, that's never going to help me get to 55. But look what happens when we switch around the 1 and the 9. First thing, you guys told me, or we talked about the fact that they both have to be negative, because a negative times a negative is going to give me this positive 9. So 6x times negative 9 is negative 54x. X times negative 1 is negative 1x. Negative 54 plus negative 1 checks out to be negative 55. So we have 6x minus 1 as a factor, and x minus 9 as a factor. Again, notice how I am writing them times one another. I'm not doing something weird like 6x minus 1 and then x minus 9, like stacking them on top, or like even putting them in parentheses. Like, that's bad news. We want to show that there's two binomials being multiplied by one another.